Okay, we're just going to take a look and talk a little bit about this cat data. First thing that we need to do is make sure that our graph reflects our variables. So we've got heart rate on the x-axis, and we've got body weight on the y-axis. So when we go to describe our variables, what are the variables and what are they and what do we call them? So the heart rate is our explanatory variable, it's on the x-axis, and our body weight is the response variable on our y-axis. And we've talked about the fact that we could reverse this, but this was what we were going to go with based on our scatter plot and the way it was entered into Excel. And then I drew a straight line through a line of best fit, what I estimate to be a line of best fit or a trend line for this. And then I will go into my analysis. I also will do on the day, I'll have to write a plan about how I collected my data and how I kept my variables consistent. And, you know, with this data provided for you, we can't really do that to that extent. I mean, we can talk about in the conclusion a little bit or as an introduction that we realize that heart rate and body weight of cats, in order to take a heart rate, the cats would have to be deceased. And that then presents itself a whole different kettle of issues around whether the cats were healthy, whether they were old, and that might affect their heart rate, and if they were diseased, that might affect their heart rate and their body weight, and so on. So there's things that you could discuss with limitations or problems with the data, but we're just going to go on with the analysis. So the first part would be direction, and the relationship of the cat heart rate and body weight is a positive relationship because it's generally constant change going in and upward from left to right, and we know that the fact that it's positive, we know that it's positive because as one of the variables is heart rate increases, the body weight increases. So you always want to say the x first and the y second. So heart rate increases, body weight increases. The strength, it's a moderately strong relationship, and that's because most of the data points are quite close to the trend line, but they're not all close to the trend line. There is a little bit of scatter and a little bit of distance away from the trend line. So we could say it's strong, but probably moderately strong would be a better way of identifying the relationship as opposed to strength. The scatter is linear, mostly because you know, the dots are following the trend line, and they're increasing at a fairly constant rate. There isn't much scatter. I mean, the scatter is pretty consistent. I could draw some bands in here and, you know, just freehand it. But, you know, if you draw a couple of band lines that are parallel to the trend line, you can see that, you know, that scatter is fairly consistent. It's not really fanning out. I mean, we might have a little bit more at the end here. There might be a little bit more fanning out and a little bit further away from the trend line than some of the other points, but just basically we have less points. There is an unusual point here. That can be an unusual feature where we've got, so we can talk about that when we get into anything unusual. So the scatter is fairly consistent along trend line. However, there's one piece of unusual data. The unusual piece of data is, in this case, it's 20.5 approximately. I mean, we can find it from the raw data, but about 20.5 and 3.9. You could get it off the graph, but you can go into your raw data to get that, right? You could go into your raw data to find that. Now, what does that mean? Basically, you know, that means that we have a fairly large heart rate for the body size, and that's why it's quite a bit far away from the other data. So, you know, the fact that the heart rate's quite large compared to the other data might suggest that that was a cat with a disease like that. Not sure. And then you would get into the gradient, which I haven't done in this particular video, but we'll talk about the gradient and any limitations of the experiment. So any issues or limitations, this is a limit of sourcing all the cats. You cannot weigh their heart while they're alive. The body weights might also differ with different breeds of cats. So the body weight of cats will also differ because of how much the cat is fed, whether they're overweight, the breed. There's a fair bit of issues around the limitations. Also, there's limitations with the model because as we extend the line, right, as we extend our trend line, we start to get into negative areas, and you can't have, you know, sort of an infinite heart weight for a cat, I mean, probably in grams, there would be a limit as to how big a heart a cat can have. So extending the line is a bit of an issue. So you can talk about those kinds of things.